Hello, in this video we'll be constructing the four Suvat equations. Now in this graph I've plotted velocity in seconds on the y-axis against, sorry, that's not nonsense, velocity in meters per second on the y-axis and time in seconds on the x-axis. Now what I have here, I have a straight line representing the motion. So the motion starts with initial velocity of u up to a final velocity there of v. Now let's go and construct the equations. Now the first equation, number 1, can be thought of simply as the gradient is the acceleration. The gradient of the velocity time graph is the acceleration, and the gradient is simply v minus u divided by the time. So if we construct this like that, so we have acceleration is equal to v minus u over time. I should just turn my alarm clock off. Right, that's better. It's a funny time for alarm clock, it's quite late in the evening. So, that's the first one. And that can be arranged to be AT is V minus U, which will give you, eventually, will give you AT plus U equals V, so V equals U plus AT. And that is equation 1, and I shall just move that to the top. So number 1 was V equals U plus AT. Now the second equation, number 2, is simply stating that the displacement is equal to the average velocity, which is v plus u over time. That's the way you find an average. It's just the sum divided by the number of items. So the distance or displacement equals the average velocity, all multiplied by the time. From the equation, speed equals distance over time. Distance equals distance equals velocity times time. Okay. The third equation, we're going to work out from the area under the graph, because the area under a velocity time graph is equal to displacement. So we have two areas, area A and area B, and we'll add them together. So area A, so the total displacement is equal to area A, which is u times t. That's a very good roll. Which is ut plus, now here we have time, or let's say a half time, half the base, it's a triangle, half the base multiplied by the height, and the height is v minus u. Now, from earlier, v minus u is equal to at, so therefore displacement equals ut plus a half times time times acceleration times time, which will give us a third equation, which S equals ut plus a half a t squared. Now the fourth equation, we want to have an equation without time in it, because we've got time in that one, time in that one, time in that one. We want an equation without time in it. Okay, so what I'm going to do is I'm going to use equations 1 and 2 and eliminate time. So we shall rub this one out. So, right, now from equation 1 we get time is equal to v minus u over a. That's from equation 1. So I'm now going to substitute that value for time into there to give me s is equal to v plus u over 2 multiplied by v minus u over a. Now, if you're familiar with mathematics yet, that is the difference of two squares, because v plus u times v minus u will give equal to v squared minus u squared. So that becomes v squared minus u squared over 2a. So what we do then is we rearrange that equation, and I'm going to rub these two at the top off. So the 2a comes across, so 2as is equal to v squared minus u. Therefore, the fourth equation will be v squared equals u squared plus 2as. So to summarize all the equations we constructed today, they are as follows. Number 1, v equals u plus a t. Number 2, displacement s equals u plus v, that's the average velocity times time. Number 3, we got from the displacement and the velocity times graph, which equals e to the ut plus a half at squared. And we want to eliminate t to have an equation without time in it, and we got v squared equals u squared plus 2as.